Hey guys, all right, so you should have first watched a video on the first 4 questions of this packet, okay? And you should have notes next to all of these examples. Now, before you're watching this video, you were supposed to try 5 through 8 on your own, as well as 12 through 18 evens. So if you didn't try them on your own, try them on your own first, and then you can start up this video and watch the answer, the answer key, and see how you did. All right, so I'm gonna kind of move this up a little and zoom in so we can get started. All right, so the first question that you had to try on your own was number 5. Now, you can see here that, we have a 3 on the right-hand side of the equation. Before you get started, you always want to get all terms to one side of the equation. You want to have one side of the equation set equal to 0. So basically, if I take a 3 and move it to the other side of the equation, it's going to become a -3. I mean, if you want to show the work for that, you definitely do not have to at this point in math. But what you would be doing is you'd be subtracting 3 from both sides of the equation. So that would leave you with 2x squared plus 5x minus 3 equals 0. Okay? You don't have to show this right here. It's implied that when you move something from one side of the equation to the other, its sign changes. All right, so now what we're going to do is we're going to factor this and make a t-chart and solve. Now, the terms we have, this is written in standard form. So, right, the exponents go in descending order. So here you want to say, can I factor out a greatest common factor? Which I can't. So because my number in front of the first term, right, we call that the leading coefficient, because that's something other than a 1, what we're going to do is we're going to do the rainbow, which leads us to factor by grouping. All right, so we know when we do factor by grouping, we do not set up 2 sets of parentheses, okay? What we do is instead, we bring down the first term. I'm going to leave a big space, and I'm going to bring down the last term. And don't forget to bring down the equals 0. This is super important because you want to keep it as an equation. Without this equals 0, it's no longer an equation, it's an expression. So you will, lose a point for that. All right, and then what we do is we make a rainbow from the first number to the last number, and we multiply that. All right, so 2 times -3 is -6. So what we have to do is we have to come up with 2 numbers that multiply to -6 and that add to -5. All right, so that would be +6 and -1. So I'm going to write +6, and don't forget, if this has an x, we need to attach an x to it, so +6x, and then -1x, which you could just write as -x. If you want to put -1x, you can. All right, so now let's group, and out of the first 2 terms, we could factor out a 2x, leaving us with x plus 3. Out of the next 2 terms, we either have to factor out a +1 or a -1. Well, since here we have positive, this says negative. This is the opposite signs of what we want. So we want to factor that negative out. So I'm going to factor out a -1, which would leave us with a +x and a +3, right? Because a negative divided by negative is positive. Same thing here, negative divided by negative is positive. And please, again, do not forget to bring down the equals 0. You have to keep it as an equation. Okay, so now we're just going to take what's in front of these parentheses and group them together as one of our factors. And then we're going to bring down the x plus 3 as our other factor and the equal 0. So now that we have this in factored form, we can solve. You're going to take each one of these factors and set them equal to 0. I like to separate them by putting a line down the middle and crossing it like that. I call that a t-chart, just to separate your work. So you would set each factor equal to 0, and solve. Okay, so over here to solve, we would add 1 to both sides of the equation, leaving us with 2x equals 1, and then when we divide by 2, that gives us x equals 1/2. Okay, over here, we're going to subtract 3 from both sides of the equation, and that leaves us with x equals +3. All right, so I'm going to circle my answers, or you could box them off, whatever you want to do. Just, make it known what the final answers are. Now, just something I want to point out. Here, since our biggest exponent is a 2, what that tells us is we're going to have a maximum of 2 answers, which we do. The only time that you would have, less than 2 answers is if you wound up with 2 of the same answers, like x equals 3 and x equals 3. Okay, that's called multiplicity. If you had more than one of the same answer, then you'd have, less than the degree of the function. The biggest exponent is called the degree of the function. Also, one other thing, if you wanted to check these, you easily could. You could take this value, substitute it in for x into the original equation, and see if the left-hand side of the equation equals the right-hand side of the equation. All right, so let's take a look at number 6. Now this one, the equation is already set equal to 0 for us, so that's great. So we could just start off by factoring. Now, since the exponents are in descending order, it's in standard form, let's jump into it. We could say, all right, can I factor out a greatest common factor? And yes, you could see here, we can factor out an x squared. So let's do that. And that'll leave us with x squared minus 18x plus 65. All right, and then again, don't forget to bring down the equal 0. It's super important to keep it as an equation. All right, so let's bring our x squared down. And this factoring actually isn't too bad. Because we have a 1 in front of our x squared, this is the AM method. What that means is the add, multiply method. So we set up 2 sets of parentheses. And since we have an x squared in our first spot, we're going to put an x and an x in the first spot within each parenthesis, because x times x is x squared. And then you're going to come up with 2 numbers that multiply to 65 and add to 18. All right, so let's see. That's going to wind up being negative 13 and negative 5. Okay, so this time I'm going to separate all of my factors. And I'm going to set each one equal to 0. Okay, so let's start off by solving this first one. Now, to get rid of a square, we just take the square root. So that leaves us with x equals. Now, technically, when you have an x squared, I'm going to do a separate problem off to the side. Like, for example, let's say we had, I'll just do it over here, x squared equals 9. When you take the square root, right, x is going to be equal to not just 3, but positive 3, as well as negative 3. Okay, this squared tells you that you could have up to 2 answers. Because think about it. If you took positive 3 and substituted it back in for x, isn't 3 squared 9, right? 3 times 3 is 9. And if you took negative 3 and substituted it in for x, wouldn't negative 3 squared, negative 3 times negative 3 also be 9? So this tells you could have up to 2 answers because it's the positive and the negative, okay? So if we come back over here, all right, so x squared tells us we could have up to 2 answers. So we could think about it as positive and negative, but here's the exception. Because it's a 0, 0 can't be positive or negative. So really, here, our only answer, oops, sorry, let me switch back to the pen, is going to be 0. You wouldn't write positive and negative 0. Okay, there's no such thing as a sign in front of your 0. So that's one of our answers. Okay, over here, if we add 13 to both sides of the equation, sorry, it's not really coming out too well, you get x equals 13. And then here, if we add 5 to both sides of the equation, we get x equals 5. Okay, so in this case, even though it was a 4th degree equation, we only wound up with 3 solutions because here, there's no such thing as positive and negative 0. Okay, so the next one you had to try was number 7. Now, if you look at this, first thing we have to do is we have to get everything to one side of the equation. Now, instead of moving this x to the 4th to the right, I know you only have to move one term, but that's going to make our leading coefficient negative, which I want to avoid if I can. So I'm going to take these 2 terms and move them to the left-hand side of the equation. Okay, so I'm going to bring down the x to the 4th. And if I move the positive 12x squared to the other side of the equation, right, it becomes a negative. Its sign is going to change. And if I bring the negative 32 to the left-hand side of the equation, it's going to become a plus 32, a positive 32. And then I'm going to bring down my equal sign. And since I moved everything away from this side of the equation, I'm left with nothing. I'm left with 0. Okay, so now we're just going to factor. So since we have a 1, since this is a trinomial, and our leading coefficient is a 1, we do not have to do the rainbow into factor by grouping. We're going to do add multiply method. So I'm going to set up 2 sets of parentheses. And since this is an x to the 4th, I'm going to put an x squared in the first spot in each parenthesis. And then 2 numbers that add to negative 12 and multiply to positive 32 are going to be negative 4 and negative 8. All right, so if you would like to factor this further into x plus 2 times x minus 2, you can. Okay, and then you make your t-chart and you'll get x equals negative 2 and positive 2. Now I'm going to show you a different way, only because it's going to help us when we go to solve this factor, when we set this factor equal to 0. All right, so this is the other way you can do it. You can just set up a t-chart. So even if you don't factor completely, you can still get the right answer in the end. All right, I'm going to take each of these factors and set them equal to 0. This one you may have had a little trouble with when you were finishing up. I'm not sure. Okay, so I'm going to add 4 to both sides of the equation, leaving me with x squared equals 4. And we know to get rid of a square, we take the square root. And just like I was saying on the last question, if you have an exponent of a 2, that tells you could have a maximum of 2 answers. So in this case, we actually are going to have 2. We're going to have x equals not just 2, but positive 2 as well as negative 2. Because think about it. Positive 2. If you take positive 2 and square it, doesn't that give you 4? Right? 2 times 2 is 4. And if you take negative 2 and square it, negative 2 times negative 2, isn't that also positive 4? So both of these 2 answers were positive 2 and negative 2. If you prefer to write it out as x equals 2 and x equals negative 2, you can. All right, now on this side, this is the one that might have been a little tricky. If you add 8 to both sides of the equation, you get x squared equals positive 8. Now, when you take the square root, 8 is not a perfect square. So all we're going to do is we're going to just simplify that radical. All right, so first, let me bring down the x equals, and we know that this squared tells us we could have 2 answers, so I'm going to put positive and negative. Now, since 8 is not a perfect square, we want to break this up into 2 separate radicals, where basically in this radical, you're going to put the biggest perfect square that divides evenly into 8, and then this will just be our leftovers. So the biggest perfect square that divides evenly into 8 is 4. So I'm going to put a 4 in this one. And then isn't 4 times 2, 8? So I'm going to put a 2 in this one. All right, so now I'm going to bring down my x equals plus and minus. Now we know the square root of 4 is equal to 2. Okay, the square root of 4 is 2. So I'm going to bring down a 2. And then whatever's left over here, as long as you took out the biggest perfect square possible, this should not simplify. 2 is not a perfect square, and radical 2 doesn't break up into anything smaller, so I'm going to bring that down as radical 2. So on this side of our t-chart, we got x equals plus 2 radical 2 and negative 2 radical 2. So we have 1, 2, 3, 4 answers. And if you wanted to check, you could always take, for example, positive 2 radical 2, plug it in for x here, plug it in for x here, and see, you could do it in a calculator, see if both sides of the equation are equal to each other. You could do that for all 4 of the answers one by one, and just make sure it checks. All right, so let's take a look at number 8. Now, number 8, this one's actually not so bad, because the right-hand side of the equation is already set equal to 0. And when we start off with 4 terms, after we look and say, all right, there's no greatest common factor, we could just jump right into grouping. Okay, so out of the first 2 terms, it looks like we could pull out a 4x squared, which leaves me with a 2x plus 1. Now to the next 2 terms where you have to say, all right, well, am I going to pull out a negative 9 or a positive 9? Well, since the signs in my parenthesis here are positive, positive, and these are negative, negative, we want to get those negatives out of there. So we're going to factor out a negative 9, which leaves me also with the same thing. Positive 18x divided by, negative 18x divided by negative 9 is positive 2x. And then negative 9 divided by negative 9 is also positive 1. So I'm going to bring down my equals 0. Now what we see here is that the 2 parentheses match up. Okay, so when that happens, let's take what's in front of the parentheses and we'll group them together. And then let's rewrite that common binomial of 2x plus 1. Now when you're solving an equation, okay, this can factor further. If you want to factor it further, you can. If you don't want to factor it further, you will still get the same answer in the end. Okay, I'll show you what I mean. So let's do it like this. The last question we didn't factor further in number 7. So let me factor this further. I'm going to factor this. This is dots. So the square root of 4x squared is 2x, right? The square root of 4 is 2. The square root of x squared is x. So let's put a 2x in the first spot in each parenthesis. We're going to make one positive and one negative. And then the square root of 9 is 3. So we'll put a 3 in the second spot in each parenthesis. And then let's take our 2x plus 1 and bring that down. Okay, so now if we separate all of our factors and set each one equal to 0, let's solve. Okay, so here we're going to subtract 3 and divide by 2, which leaves us with x equals negative 3/2. Or if you want to write that as negative 1.5, you can. All right, here we're going to do pretty much the same thing, except we're adding 3. So we get 2x equals 3. And then when we divide by 2, we get x equals 3/2, positive 3/2. So if you want to write 1.5, you can do that instead. That's up to you. And then here I'm going to subtract 1 from each side and then divide by 2. So it leaves me with x equals negative 1/2. Or if you want to write negative 0.5, that's fine. Now, I just want to go back for a minute and I want to show you that if we did not, let me just change to another color. If we did not factor this further, if I had taken this, the 4x squared minus 9, and set that equal to 0, I could solve that and I would still get these two answers. I'll show you why. So I'm going to add 9 to both sides of the equation. So it gives me 4x squared equals 9. And then I'm going to get the x squared by itself by dividing by 4. So it gives me x squared equals, I'm going to leave that as 9/4. Now, when I take the square root, I'm going to have x equals, and remember, this square tells us we could have two answers. So we're going to have a positive as well as a negative. And since the square root of 9 is 3, and the square root of 4 is 2, when you take the square root of a fraction as a whole, you would get 3/2. So here we get x equals positive 3/2 and x equals negative 3/2, which is what we got when we factored further. So you could do it either way that you prefer. Okay, if you turn to the next page, you had to do 12 through 18 evens. All right, I could do 12 3 different ways, but I think what I'm going to do is I'm going to just stick with what we've been doing, okay? I'm going to first, you see we have a greatest common factor here, so I'm going to first factor out the greatest common factor, leaving me with x squared minus 9 equals 0. And then since the x squared minus 9 factors further, I'm going to break that up into x plus 3 times x minus 3. Now, there was so many different ways you could do this question, but I just stuck with the most direct, the most basic way. So now I'm going to make a t-chart. I'm going to separate my factors, and I'll set each factor equal to 0. And then we're just going to solve. Now, with this first one here, there's nothing to solve. It says 4 equals 0. Well, that's not even a true statement, right? 4 equals 4 or 0 equals 0. 4 does not equal 0. So that we're going to cross off. Okay, that's not true. All right, now in the middle here, we're going to subtract 3 from both sides, leaving us with x equals negative 3. And then over here, we can add 3 to both sides, leaving us with x equals positive 3. Okay, so we get positive 3 and negative 3. You know, if you don't want to show this work, you don't have to. I mean, if your factor is x plus 3, you know your x value is going to be x equals negative 3. And if you have a factor of x minus 3, the x value, the answer will have the opposite sign. So if you want to jump right from here and just writing the answer, you can. You do not have to show this work. All right, number 14. All right, so with number 14, we first have to get one side of the equation set equal to 0. So you could show minus 8 from both sides of the equation, but we know when we move a term from one side of the equation to the other, its sign changes. So when I take this 8 and move it to the left, it's going to become a negative 8. All right, so I'm going to have 6p squared plus 13p minus 8 equals 0. Okay, so we have a trinomial. You first want to say, can I factor out a greatest common factor? Which I can't. So because we have a number other than 1 in front of our first term, we're going to have to do factor by grouping, okay? Which means we're going to have to do the rainbow. All right, when we do that, we do not set up 2 sets of parentheses, right? This, no good. We don't do that. What we do is we bring down the first term, we leave a big space, and we bring down that last term, and we come up with 2 numbers that multiply to negative 48 and add to positive 13. All right, so it may take a little bit of trial and error, but we wind up getting, I guess, a positive 16 and a negative 3. So we're going to put a plus, doesn't matter what order you do it in, plus 16p, right? If this has a p on it, we need a p here. And then minus 3p. And again, you could have done it in the other order. Some of you might have liked to do it in the other order just because, like, some of you think, oh, look, a 6 and a 3, it's easy to factor out a greatest common factor. And a 16 and an 8, it's easy to factor out a greatest common factor. So you totally could have done that. All right, but I didn't. I chose this way. So now, when I group together the first 2 terms, I could pull out a 2 and a p, which is going to leave me with 3p plus 8. Okay, so now when we group these 2 terms together, the only thing we could pull out is either a positive 1 or a negative 1. Now, since this is a positive, this is a negative. This has opposite signs of this. So that always tells us we're going to pull out a negative. So I'm going to pull out a negative 1, which would leave me with a positive 3p and a positive 8 in parentheses, which is great because now if you see, look, our parentheses match up. So I'm going to group together what's in front of those parentheses. So 2p minus 1, and then I'll rewrite the 3p plus 8 and bring down the equal 0. You have to bring down the equal 0 in every step. If you forget that, you're taking it from an equation and making it into an expression. We don't want to do that. All right, so we're almost done. All we have to do is just take each factor and set it equal to 0. And you're just going to take these and solve them. So on the first one, when we add 1 and then divide by 2, we wind up getting p equals 1/2. Okay, if you want to write that as 0.5, you definitely can. On the next one, we wind up getting p equals negative 8/3. Now this one, if you try to plug in your calculator negative 8 divided by 3, you'll get, what do you get, negative 2.66666 repeating. Okay, you could never round. If you get a decimal that keeps going and going, just don't write it as a decimal. Leave it as a fraction because a fraction is the exact answer. This is exactly what it's equal to. Okay, if you get a decimal that keeps going, don't round on your paper. So for this one, we get negative 8/3. All right, number 16, we're almost done, only 2 more. All right, so number 16, I look at this and I say, all right, can I factor out a greatest common factor? And keep in mind, the equation's already set equal to 0. That's why I'm jumping right into it. Yes, I can. I can pull out an x squared. So when I do, it leaves me with x squared minus 11x plus 18. And I'll close my parentheses and bring down the equal 0. All right, so let's bring that x squared down. And now we have a trinomial where the leading coefficient is 1. So that's usually the quick factoring, right? We set up 2 sets of parentheses. And since this is an x squared, we're going to put an x in the first spot in each parenthesis. And then we're just going to come up with 2 numbers that add to negative 11 and multiply to positive 18. All right, if they multiply to a positive, they have to have the same sign, right? And since they add to a negative, it means both of them are going to be negatives. All right, so we're going to use a negative 9 and a negative 2. All right, you want to look and say, can I factor further? Nope. Even though this might appear to, it's not a difference of perfect squares because this is an x, not an x squared. So we're going to make our t-chart. And if you take, I'm going to do this, if you take x squared and set it equal to 0, to get rid of the square, you take the square root. x equals, no, normally when you have a square, when you take this, when you take the square root of something that's squared, we write plus and minus. But since there's no such thing as positive and negative 0, we're just going to write 0. So that's one of our answers. So now let's do the shortcut. If we set this factor equal to 0 and solve, basically you're going to wind up with the opposite sign of what we see here. So we're going to wind up with x, don't forget the equal sign, x equals positive 9. Okay, same thing over here. If this says x minus 2, we're going to wind up with x equals positive 2. Okay, so really you're just switching the sign. All right, so if you flip the page over, we're on our last one, number 18. Okay, so now if you notice, we have terms on both sides of the equal sign. So we're going to get them all to one side. Since the term with the biggest exponent is already has a positive leading coefficient, I want to leave this where it is. So I'm going to move the terms from the right to the left-hand side of the equal sign. All right, so when we do that, I'm going to bring down the 32 m cubed. I'm going to bring down the 16 m squared. And remember, when you move a term from one side of the equation to the other, its sign changes. So when I move this over, it's going to be a negative 18m and a negative 9. So we'll write minus 18m minus 9. And since I moved everything away from the right-hand side of the equation, that's equal to 0. Okay, so now you can look and say, well, can I factor out a greatest common factor? No, there's nothing that divides evenly into all of these. So I'm going to jump right into grouping. All right, so to the first two terms, let's see, I could factor out a 16m squared, which leaves me with 2m plus 1. Okay, to the next two terms, I could factor out a negative 9, which also leaves me with 2m plus 1. And don't forget to bring down the equal 0. Now we're going to take what's in front of our common binomial, and we're going to group those together in one parenthesis. So 16m squared minus 9, and then you can bring down the 2m plus 1, and the equals 0. Now, if you want to make a t-chart at this point, you definitely can, okay? If you want to factor this further, you can do that as well. I guess I'll just factor this further. So we could see that this is dots, right? It's a difference of perfect squares. So since the square root of 16 is 4, and since the square root of m squared is m, I'm going to put a 4m in the first spot in each parenthesis. One's positive and one's negative. And then since the square root of 9 is 3, I'm going to put a 3 in the second spot in each parenthesis. And you can bring down the 2m plus 1, and don't forget about the equal 0. All right, so now we have everything's fully factored. Let's separate our factors and solve. All right, so we're going to set each one of these equal to 0. All right, so just solve them. Here we're going to subtract 3, which gives us 4m equals negative 3, and divide by 4. So we could write m equals negative 3/4. Or if you want to write that as negative 0.75, that's fine as well. Now, this one, shouldn't we just wind up with the positive of this, since this was a minus sign and this was a plus sign, but we could show it, okay? If you want to just jump right to the answer, I'm okay with that too. So here, when we add 3, we get 4m equals positive 3. And then when we divide by 4, we get m equals positive 3/4. So if you want to write that as positive 0.75, you can. And then finally, we're going to subtract 1 and divide by 2. And when we do, we get m equals negative 1/2 or negative 0.5.